Hello, welcome to Build Succeeded. My name is Lucian and this is the 6th episode of the 3D engine series, where we are going to load a 3D model in our engine and implement Z-buffer. If you haven't seen the previous 5 episodes, I've added links to them in the description. I encourage you to watch them as we are going to continue from where we left last time. Let's get to it. I've searched for a simple 3D model with a single texture to load and display in our engine and came across this nice model from an artist called Emilia Rules on GTrader. I've added the link to the model and the artist in the description. To prepare the model for our engine, I loaded it in Blender, then I made sure to triangulate all faces because our engine only works with triangles and cannot load a surface with more than 3 points. Then I saved it in wavefront format with OBJ extension. That is because this format is a text format and easier to read. Take a look at the OBJ file Blender created when I exported the model. Each line starts with a string. Lines that start with V represent points or vertices. And after V, we have a set of 3 floating point variables representing the 3D coordinates for that point. Lines that start with VT represent texture coordinates, with 2 variables representing U and V between 0 and 1. There are also lines that start with VN, which represent normals, but we won't use those since we are calculating our own normals. Finally, the lines that start with F represent faces, or triangles in our case. After the letter F, we can find 3 groups of numbers separated by space. Each group represents a point of the triangle. In each group we can find 3 numbers separated by a slash character. The first number here represents the index of the V or vertex line from earlier, where we can find the point's 3D coordinates. The second number is the index of the VT line from earlier, where we can find the texture coordinates for this point. The third number is the index of the VN line, so we won't use it. This indices starts with 1, not 0. And this is the texture we're going to use. Looks like a simple image, but I had to flip it vertically and save it in a specific format, RGBA, in order for our engine code to read it correctly. To accomplish this in code, I'll create a new class called Blender Object. The class implements GameObjectBase, of course, and will have 2 fields to store the names of the OBJ file and texture file. It will also have a pointer to the texture, so we can store it after load. The scale variable is used to scale the object up and down. Usually the 3D models have small sizes, close to 1, and in our engine 1 represents 1 pixel, so the object would be very small. Now let's work on the methods. First, the constructor will simply save the file names sent to it and initialize the position and rotation. For now we'll use a hard-coded value. Now the most important method, load. First it loads the texture using our usual method. Then we open the OBJ file. I'm going to define 2 vectors, one for vertices and the second one for texture coordinates. Then, reading the file line by line, we check if a line starts with V, we read the 3 variables and create a point 3D from them. We also check if the line starts with VT and we read the U, V variables. We store these in a point 3D as well, but only using the U and V part of the point 3D structure. After we load the vertices and texture coordinates into vectors, we reset the file pointer to the beginning of the file and we read it line by line again, but this time we're looking for lines that start with F. If we find them, we read the 3 groups of numbers one by one and then we create the 3 points of the triangle based on the red indices and the earlier created vertices and texture coordinates vectors. Then we simply form a triangle from these 3 points. You've probably noticed that the Y coordinate is added with a minus, and that's because usually the Y coordinate in Blender points up, while in our engine it points down. The 3D model and world would be drawn upside down, so I'm doing it to flip the model vertically. I should have fixed this somewhere else in the project, probably in the projection stage, but at this point I'm okay with it here. Also, if you notice the P1 and P2 points being switched when creating the triangle, that is because I didn't check the normals in Blender before exporting the 3D model to wavefront format, and they are pointing inside the model right now. To fix that, I've just switched second and third points. I'll also override the logic method to rotate the object so we can see it better. To demo this, in the engine class, I'll initialize the new 3D object with the names of the file and scale. Then I'll call load to load the model and add it to the engine's pipeline. If we run the project now, we can see the model loaded and displayed on the screen. Okay, now let's take a look at the Z buffer. The Z buffer is a matrix containing the Z coordinate of each pixel on the screen, depending on the triangle it comes from. This will help us display complex 3D models better, so we don't see parts of the object that are behind other parts by mistake. Right now, we're doing that by sorting all the triangles before drawing them based on the average Z of the triangle. So those that are in the back are drawn first. Let me show you what happens if we comment out the sorting part of the engine. The model looks weird, a bit transparent. The triangles are not displayed in the right order anymore. To implement the Z buffer, I have to add another array of doubles to the engine base class, called Z buffer. We are going to clear it every frame and send it to the triangle, so the triangle can use it to draw. Now let's go to the triangle class, the draw method. After adding the new parameter as a pointer to the buffer, we're going to calculate the Z coordinate for each pixel, similarly to the U, V and W coordinates. After we have the Z coordinate, before calculating the color, we're going to check the Z coordinate against the Z buffer. If the Z buffer is not set yet for that pixel, it's 0, or the pixel's Z coordinate is in front of the old value in the buffer, only then we display the pixel and set the Z buffer with the new value. Let's see what happens now. We're still not sorting triangles, but you cannot see the same weird effect as before. This Z buffer method has a similar effect as the triangle sorting method, but it's more precise, since it's a per pixel method instead of per triangle, so it should look better, especially with complex models. At this point, we're done building the base part of the engine, but stay tuned. In the future, I'll build an actual game on this engine and show it to you in a video. What type of game would you like to see built on it? Thank you for watching this video and the 3D engine series. Give me a like if you liked the video and make sure to subscribe. More videos will follow, so I hope to see you on the next ones. See you soon.